Here in this system, in this figure, as you see, we have two objects on the rough surface. We have a friction basically here. Coefficient of friction is given. Let's say K. And here between this object M2 and the M1, no friction, smooth here. Friction only between M1 and the surface table, let's say. As usual, first of all, we should draw free body diagram, forces acting on each object. Let's start with M2. Downward we have a M2G and two reaction forces here and here, and it's obvious that it will be same because everything is symmetrical. Masses are equal, same friction, so we can assume that reaction forces between both objects will be identical, same. Let me call it N2, here also N2, and it's perpendicular to this surface. So these are the three forces acting on this object M2, and there is only one way it will move downward. Actually, here we have two options. It will move downward or it will stay at rest, because we have a friction and the friction might be very big and the system might be at rest. So at the moment we don't know and we cannot guess, because mass or data of this problem, mass is not given in kilograms, coefficient of friction is not given, and the angle also is not given. Everything is in terms of symbols. So we don't know, but here we have only two options. System will be at rest, no motion, or M2 will move downward, and two objects M1 and M2, one will move to the left, one will move to the right. At the moment I will assume they will move downward. M2 will move downward. Its acceleration equal to A1. Now let's come to M1. We can consider only one of the M1 because they are identical. They will have same acceleration in terms of magnitude. So that's why I will consider only one of them. Here we have a M1G. In this direction we have the same reaction force N2 and the friction force to the left. Let's call it FF. And it will move with acceleration A1 to the right. Upward we have a normal force, let's call it N1. Contact force, normal force between this table surface and the object M1. Now let's write Newton's second law for each object. Let me repeat. M2, upper object, will move exactly vertical downward because everything is symmetrical. Angle, two objects at the left side, right side, same. That's why M2 will move exactly vertically downward. Let me draw free body diagram again separately for M2. Downward we have M2G and the reaction force. This reaction force, let me draw in terms of components. Upward we have 2N2, 2 because we have two forces, symmetrical, and now we need to find sine alpha or cosine alpha. We should be careful. 90 degree. So this angle will be alpha. No, sorry, it's not alpha. Here 90 minus alpha, so this angle is alpha, should be alpha. So this is a vector basically. So here it will be sine alpha. So basically it's a vector. And the horizontal component is not important because it will not move in horizontal direction. That's why I will not draw it. So it will move downward with acceleration A2. So according to the Newton's second law, M2G minus 2n2 sine alpha equal to m2a2. Now let's come to the object m1. Let me draw free body diagram for m1 again. Downward we have a m1g, upward we have a n1, downward we have a n2 times sine alpha, reaction force between m2 and m1, and to the left we have a friction force, and it will move to the right with acceleration a1, and the horizontal component of n2 will be directed to the right, n2 times cosine alpha. I think that's all. So Newton's second law for this object in horizontal direction. So basically we need resultant force, net force in horizontal direction. To the right we have n2 cosine alpha. To the left we have a friction force. That's all, I think. Should be equal to m1 a1. Now let's come to the friction force. We are assuming that this system is moving, so friction force already reached its maximum value, which means coefficient of friction times n1, reaction force between surface and m1, and yes. Now we need to find n1. We know that this object m1 is not moving in vertical direction. So acceleration in vertical direction equal to 0. It means the resultant force on net force in vertical direction should be equal to 0. So upward we have n1, downward we have m1g, and downward we have n2 sine alpha, and this should be equal to 0. From here, n1 equal to m1g plus n2 sine alpha. It means friction force equal to k m1g plus n2 sine alpha. It means, let me substitute friction force into the second equation. So n2 cosine alpha minus k m1g plus n2 sine alpha equal to m1 a1. So basically we have two main equations. First one, and this will be our second equation. So how many unknowns we have? a1, a2, n2. So we need to pay attention to the first equation, n2 unknown, a2. In second equation, n2 and a1. Basically three equations, three unknowns, but we have two equations. As usual, we need one more equation in order to solve this problem, and this is we believe that it should be a relationship between accelerations. So now let's find a relationship between accelerations. That's why I will draw initial and the final position or position after some time of the system. So this is a initial position of the object m2. M1 was here, for example. And also we have a second object at the left side. I will not draw it. After some time, m2 will be here, and it will be moving downward. And this is its displacement, yes? Let's call it x2. Object m1 cube will be here, because here we should have contact. We have a contact, there is contact between two objects. And the object m1 shifted for this distance. Let's call it x1. Let's pay attention to this triangle. This is the right triangle. This height This side is also equal to x2 because this line parallel to each other. And we know that this angle is alpha. It means here is alpha. So we have a right triangle, this side x1, this side x2, this angle is alpha. So it means tangent alpha equal to x1 over x2. It means a1 over a2 because x1 is proportional to a1, x2 proportional to a2. So from here, a1 equal to a2 times tangent alpha. This is our last equation, equation number 3. And we have 2 more equations here. Now we have 3 equations and the 3 unknowns. Now we can solve this problem. Further is totally math. At this point we finished all physics part. Now we need to solve it. Let me copy here all my 3 equations. Equation number 1, m2 g minus 2n2 sine alpha m2 a2. From here a2 equal to g minus 2n2 over m2 sine alpha. Equation number 2, n2 cosine alpha minus k m1g minus k n2 sine alpha equal to m1 a1. From here a1 equal to n2 minus m1 minus cosine alpha minus k n2 sine alpha over m1 minus kg. And the last equation, a1 equal to a2 tangent alpha. a1 equal to a2 tangent alpha. Let me substitute a2 here, a1 here, and in this equation we will have only one unknown, n2. First of all we will find n2, then we can easily come back to equation number 1 and 2 in order to find accelerations. So a1 n2, this is a1 equal to a2 times tangent alpha as here we have sine alpha times tangent alpha. Pure mass. Let's see, we should be very careful. Let me collect n2 to the one side because only n2 is unknown. From here n2 equal to m1 m2 g k plus tangent alpha divided by m2 alpha plus m1 alpha. So this is a n2. Let me leave it like this. You can further simplify it. It's just a matter of time. N2 is given. Now we can come back to the equation number 1 and find a1 and a2. For example, a2 equal to g minus 2n2 sine alpha over m2. You need to just substitute it n2 here into this equation and find acceleration a2. It's just a matter of time.